Hello, my name is Ibuka Nkoro and I'll be sharing this paper, Malware Traffic Classification using Convolutional Neural Network for Representation Learning. And then we understand that malware are one of the vulnerabilities that affect organizations because they strip the organization of productive hours and they also affect their performance of computers or various network resources. So it is very important for organizations to um, find out good measures to prevent or like to categorize and detect this malware before they harm users or computing resources. And then various methods for um, identifying this malware have been before now. Various authors have evaluated and researched the port classification method as a good measure for detecting malware. But in an encryption setting, the port classification does not work best, just like in the case of the use of deep packet inspection, which doesn't work very properly too. And that is why machine learning has been adopted as a good measure to classify malware. And then the various kinds of machine learning, which includes the traditional machine learning, supervised, unsupervised, and semi-supervised, and deep learning, have been all good measures to classify malware traffic. And so for this paper, the authors used the convolutional neural network for representation learning of malware traffic. So I'll just head to the system design. For the system design, we consider the network traffic which are generated in form of the PCAP files, and they could be generated using network simulation tools like Nmap, like Wireshark, like T-Shark, and other uh, traffic simulation tools. And then when they are captured, the essence of this system design is to capture this raw traffic data and then use binary classifiers into normal or malware traffic, and then the 20 class classifier using the CNN to represent these data or categorize or classify these data into the normal or the or the malware traffic classes. So this is the system design as shown in this slide. So next we move to the stages for the generation of these system design. How did we come up to this aspect? And so our knowledge here is that the authors here try to apply representation learning approach to malware traffic classification using raw traffic data. And then we see that the best type of traffic is gotten in session with all layers through the experiment. For the first stage, they captured traffic using the session flow method, and then it's also a good way to identify malware. Some authors identify other kind of attacks on organizations, maybe based on time features, but this system design or this malware identification method uses the session or flow generation. That means the source IP, the destination IP, the time features, and all of the session flow to categorize features, to categorize traffic. And then next, there is the stage sanitization, where also the next stage involves the emptying and the removal of duplicate files. So files with null values are removed and confirmed to a uniform length. And then the image generation is then gotten, which is a remarkable aspect of the experiment, whereby they convert the PCAP files to grayscale image. They map them to grayscale image, and then the IDX files are generated, which is going to be fed in for the CNN model. So this forms the data processing procedure. And then next we look at the 9-step performance evaluation. The stated goal here is to use a representation learning malware classification method. So other authors have used port number, deep packet inspection, traditional machine learning, but this author is kind of the first author to use a representation learning for malware classification. Then performance metrics are outlined as the detection rate and how fast can the model detect the malware and and the normal traffic. Then the accuracy, false alarm rate, F1 score, and resource usage are also very credible metrics that are outlined in this paper. Next, we look at the system and workload parameters, which is the network traffic. The factors and values are the input, which is the USTC TRC 2016 traffic dataset. And then next, the output is going to be the benign and malware classes. The benign traffic talks about the normal traffic, which should go ahead and be assessed by any user coming into an organization or accessing any resource, or malware classes that are vulnerable to the organization or the network resource. So the evaluation technique here uses an experimental simulation. Simulation here is carried out from start to finish to evaluate the behavior of this malware. And then the workload involves network feature mapping, network traffic feature mapping. How do we convert the raw traffic data to a grayscale image? We map them evenly, and then they are now used to to train the CNN model in the form of IDX in the IDX format. So the design experiment takes into consideration the software framework, TensorFlow, Ubuntu Server, Dell Core CPUs, 16 gig of RAM, and K420M GPU accelerator. So for the analyzation and the interpretation of data, we use representation learning, as I already mentioned, PCAP files to IDX files, and then also use binary classification to to evenly separate and distribute the normal class of malware from the normal traffic data and the malware traffic data. And then finally, for the results representation, the results in the F1 score and all of, as mentioned, the performance metrics are represented in bar charts and tables. Thank you for listening, and my name is Ebuka Nkoro.